Hey guys, how's it going? I want to talk about section 2.5 today. But before I start going over 2.5, I want to make sure everybody has to have their own calculator before you start this unit. Um, this emulator, again, if you go to my website, at the very bottom of the website, you can download those two files there. This is the application, but you need the ROM image as well. If you need help installing that on your computer, let me know. You can also download that Wabbit on a non-Apple device, or you can just use your normal calculator. Most of you have your own. So if you don't have a graphing calculator yet, stop this video right now and get one before you start this. But I want you to have a calculator handy before you start the sheet. Okay. So basically, what we're doing here is we have to graph sine and cosine graphs where you're actually going to add or subtract them together. Now, I will start by saying I'm not going to have you do this the same way the book wants you to do it. The way the book wants you to do it, as you can tell, basically you'd be plotting a ton of points. We're not going to do that. So basically, here's how I want you to do this, okay? Step one, I want you to figure out both periods, okay? And another helpful tip here, you're going to want a few different colored pens, okay? Or colored pencils. If you were in class right now, I'd pass out a bunch of colored pencils. Those would actually work the best. I'm going to use different colored pens, and the different colors is really going to help you with this, okay? So first thing I want you to do is you got to figure out the periods, okay? So figure them out separately. This one is going to be 2 pi, okay? It's going to have an amplitude of 2, period of 2 pi. This one over here is going to have an amplitude of 1, but a period of 2 pi. And that's important because basically what you have to do is we have to graph one cycle of the whole thing. The period of the whole thing is going to be the greatest common multiple of both of those. Basically, if you think, you're going to count by 2 pi, 2 pi, 2 pi, so 2 pi, 4 pi, 6 pi, this one's going to go 2 pi, 4 pi, 6 pi. Well, where's the first time they're going to overlap? Well, in this case, it's likely they're both 2 pi. So the first thing I want you to do is what we're going to actually do is we're going to graph each of these separate, okay? We're going to graph y equals 2 sine of x by itself, and we're going to graph y equals cosine of x by itself as well. So what you're going to do is you're going to draw a set of axes. I'll use black, I'll do better. Okay. In this case, luckily they're both 2 pi. Well, again, we got to find that midpoint, which would be pi. This one's going to be pi over 2. This is going to be 3 pi over 2. Okay. This first one has an amplitude of 2. All right. So pretty easy to graph that one. This is a sine graph, so it's going to start at the midline, peak, midline, peak, midline. Okay. And it's important to draw these neat, okay? Neatness here is going to be a very crucial aspect, okay? Now, after that, on the same graph, we're going to draw the other portion as well, just the cosine of x. Well, that one has an amplitude of 1, has a period of 2 pi, so all the points are the same. This one starts at its peak, and it would go midline, bottom peak, midline, top peak, okay? Now, basically what we just did is we plotted points. This is the equivalent of us doing this in the book, okay? This is not actually our graph. This is just us plotting points. Now it's going to be our turn to draw the real graph. So what I would suggest you do is take that graph, and you're going to draw directly underneath it a nice, neat graph that is the same distance. And put all the points directly underneath. The neater you do this and the better you line these up, the easier your job will be, okay? All right, so again, I'm going to put the 2 pi over 2 directly underneath the pi over 2 here. Well, now all we're going to do is we're going to add those points together. At 0, the blue one's at 0, the green one's at 1. So basically what we're doing is we're adding those two together. So 0 plus 1 is 1. Over here, the green one's at 0, the blue one's at 2, so 0 plus 2 is 2. And then here we're at 0 and we're at negative 1, so 0 plus negative 1 is negative 1. Here we're at 0, here we're at negative 2, so we add them together, we're at negative 2. Okay? Here we're at 0, here we're at 1, we're adding those together, so we're at 1. Now, if I were just simply to connect the dots here, that's not really going to be enough points to get an accurate graph. The goal here is to get a very, very accurate graph. Now, what it is enough points for us to do is to now shift over and grab our graphing calculator. Okay? So, make sure, again, we are in the correct mode. You have to be in radian mode. All right, so basically what we're going to do is we're going to graph that whole thing. We're going to go to sine of x. Make sure you close that parenthesis because that's one thing. And then we're going to add cosine of x. Now, again, we have to fix our window. If we don't fix our window, we're not going to be able to transpose this graph. So, hit our window. Our graph is starting at 0. Okay, that's our x min. Our x max is 2 pi. So I'm going to put 2 pi in there. What are we counting by? The scale. Well, we're putting a dash every pi over 2. Okay. Now the y min and y max, basically I want to give myself a little bit of a cushion. Okay. And I also want to look at the amplitudes up here. The amplitude of this is 2 and the amplitude of this is 1. The maximum this ever could get to, if I add those together, is 3. So basically, I'm going to give myself a tiny cushion. I'm just going to probably go to 4, okay? I know this graph will never get to 4, but the maximum it could get to is 3. And then I'm going to press graph. Now, this is what I'm going to use to connect the dots. And I want you to find each of these points on here, right? This is at 0, 1. Well, it's at 0, 1. This one we know is at pi over 2 and it's at 2. Well, that point on this graph is right about there. So when I go to connect these dots, it looks like I need to go a little higher, and that's going to start to come back down before it gets to that point, okay? And then I want to find the next point. This one's at pi and it's at negative 1. Well, how do I get from that point there to this point here? Well, looks like I'm just kind of going right through there, okay? And then again, find the next point. Well, that one's about right here, so it looks like it actually dips down before it gets there, okay? And then it looks like it pretty much just cruises right on up to there. Now, it's also important to look. You have to make sure you're starting and you're ending at the same point, okay? This one goes up 1, it has to end up 1. That's important because that helps us identify and make sure we have one full cycle, okay? So, I do expect you to draw both of these graphs. This is not your answer graph. This is your answer, okay? The calculator helped us get that answer, but in order to plot the point, or in order to get actual points, we have to make sure we're drawing this to see how we get those, okay? Let's try another one. Okay? Let's say we have something like this. Well, first, I want you to look at the amplitude and the period. This one has a period of 2 pi. This one over here has a period, 2 pi divided by a half would be 4 pi. Now, again, we're looking for greatest common multiple, least common multiple. So think of it, we're counting by 2 pi, 2 pi, 4 pi, 6 pi. This one's going every 4 pi, 4 pi, 8 pi. Well, that tells me I know the graph is going to have a period of 4 pi. Basically, where are they going to match up? So what I recommend you do is first you draw the one with the bigger period. Okay? That'll help you a little bit. Okay? So this one has a period of 4 pi. Okay? Well, midpoint would be 2 pi. Midpoint of that would be 1 pi. Midpoint here is going to be 3 pi. This has an amplitude of 1. So that graph, sine graph, midline, peak, midline, peak, midline. So it looks something like this. Okay? So that's this green one. Now, this one has a period of 2 pi, which means it's going to be done by the time it gets to here. So I need some more points in here. Okay, this is going to end up being pi over 2. Midpoint here would be 3 pi over 2. So when I draw this, again, it has an amplitude of 3. 1, 2, 3. So this one goes midline peak way up here at 3. Midline peak way down here. Now, notice this one, because it has a much smaller period, we're only got one full cycle by the time we get to here. I need them to start and end at the same point, which basically means we have to draw another full cycle. So up to 3, back to midline, down to 3. Okay, and then our graph is going to look like this. Okay, and yes, I would want you to label all of these points. That's going to be, so 1, 1.5, this is 2.5, or that, this would be 7 pi over 2. Okay? Again, I'm just adding them up, divided by 2. Now, this is again what we're going to use to draw our big graph down here. Here's our real one. Now, what I recommend you do, again, draw these as neat as you can. First, I would try as best you can to space them out accurately. Try to make sure these gaps are as accurate as you can. And the more you keep them one directly above the other, it will help you as well. Okay? The better you space these out, meaning like make sure all these gaps are the same. It wouldn't be a bad idea to grab a ruler and space them out as well. Okay, 1, 2, 3, 4. And the reason I graph that one up to 4 is when I look at my amplitudes, this one can go up to 3, this one only goes to 1. If they were peaking at the same time, it would go to 4. Now, all I do is I take these points and I graph and I add them together. The green one's at 0, the blue one's at 0. 0 plus 0 is 0. Now, this one I'm going to have to estimate, okay? Here I'm at 3. This one is at almost 1, not quite 1. Okay, so 3 plus almost 1, we're not going to be up to 4, but we're going to be almost to 4. Okay, so sometimes you are just going to estimate that point. The more accurate you draw that these curves, the easier it is going to be to estimate. This one I don't have to estimate. Here I'm at 0, here I'm at 1, so 0 plus 1 is 1. Okay, 3 pi over 2. This one's at 3 or negative 3. This one's at almost 1. So negative 3 plus almost 1 is going to be basically negative 3 plus 1 would be negative 2, but we're not subtracting the whole thing, so it's going to be a little bit bigger than negative 2. Okay? And then 2 pi, they're both at 0. So the green and the blue are both at 0. 0 plus 0 is going to be 0. So some of these points you know for sure. Some of them are just estimates. Sometimes I do like to just go through and do all the ones I know for sure, like 3 pi. This one's at 0. This one's at negative 1. So I know for sure I'm at negative 1 here. And then 4 pi 0, 0, I know is 0. And then I'll go back and estimate. Okay? Like here, this one's at negative 3, this one's at almost negative 1. If I add those together, I'm going to be at almost negative 4. Actual, like real graph paper is not a bad idea with these either. Okay, this one I'm at 3, this one's at almost negative 1, so 3 minus almost negative 1. That's going to be a little bit bigger than 2. Now again, that's just me plotting some points. I'm going to use this to actually draw the graph. Please don't just connect the dots. I don't know for sure if this graph looks like this, okay? I'm going to be very picky when I'm grading these, so make sure you're actually using a graphing calculator to connect the dots, okay? So again, I go 3 sine of x, make sure I close that parenthesis, plus sine of a half x. I would just type it in as 0.5x. That's the easiest way to type that in. All right? Now, I have to fix my window. Well, my window is from 0 all the way now to 4 pi. Oops, that's the wrong spot. That's 0. This one should be 4 pi. What am I counting by? Well, again, I'm putting a dash mark every pi over 2. Okay. I know my graph has the potential of going to 4. I'm going to probably put negative 5. I like that little bit of cushion. It makes it easier to see on the graph. And then I'm going to press graph. Okay. Now again, I want you to try to find all these points on this actual calculator. It looks like here, right at that pi over 2, that actually does end up being a peak. Sometimes it is, sometimes it's not. You know, the last one, you know, when we drew this graph, that wasn't the peak, right? So if I drew that as the peak, my graph is going to be a little bit off, okay? And again, I'm going to be very picky when I'm grading these. So this one, it does look like that ends up being the peak right there. So it's going to go up, and it's going to peak right there, and it's going to come back down. Okay, here's the pi. Pi is right there. Okay, right at 1. So, and it looks like it's just kind of cruising on through right through there. And then we get to 3 pi over 2, and again, sure enough, yep, that looks like it's a peak right there. So I can connect the dots. Okay, 2 pi is at 0. Okay, so I'll go right through there. This one looks like, again, it's a peak. So, coming down. Then again, this last one's a peak, right? I'm cruising through, and I'm peaking down there. So this one is actually a little bit easier to draw because those end up being peaks. Just know, sometimes these key points that we're plotting, they do correlate on here as actual peaks. Sometimes they're not. Sometimes we really need to have more points, okay? It is important that we are drawing these first graphs, even though they're not part of our answer. This is basically us showing our work, and it's us plotting points. We need some key points. If I just simply draw this on a calculator and try to draw the graph, I'm not going to be very accurate. I have to plot some key points so I can actually connect the dots, okay? All right, let's try a minus 1. When you do a minus 1, What I recommend you do is I recommend you think of this as a plus. Okay, and basically what that means is I'm going to do -2 sine of x plus a negative cosine of x. The reason I say that is it's easier to add than subtract. I'll show you what I mean. Basically, what I'm going to do is I'm going to graph the negative versions, meaning I'm just going to flip them upside down. Again, I'm going to look at the periods. This one's 2 pi. This one's 2 pi. So that makes my period easy. This is going to be 2 pi. Okay, period pi over 2. This will be 3 pi over 2. This has an amplitude of 2. Okay, so my blue one, sine graph, starts at 0. Now it goes down, so it's going upside down, right? Midline, peak, midline. Again, the more time and care you take drawing these first graphs, the easier your job's going to be later. This one is upside down cosine graph, so it's going to start at the bottom peak, midline, top peak at 1, amplitude's 1, right? Midline, bottom peak. So it's going to look like this. Okay? Now, the reason I drew that upside down, and now I get to add, I get to say 0 plus a -1. That's easy. If I graphed the positive version and then I tried to subtract, I'd have to keep track. Is it 0 minus 1, or 0 minus a -1, or is it -1 minus 0? That's a lot harder to keep track of. So it's just easier if you graph the upside down version, and now I get to add. Okay. So draw that graph. 2 pi, pi over 2, 3 pi over 2. Yeah, I'm going to graph this up to 3. And the reason I'm going to graph this up and down to 3 is if this one has an amplitude of 2 and this one's 1, the biggest it could ever get to is 3. And now I can now I can add these key points. So again, this one's at 0, this one's at -1, 0 plus -1, -1. This one's 0, this one's -2, 0 and -2 makes -2. This one's 0, this one's at 1. Add those together, I'm at 1. 0 and 2 should be at 2. 0 and -1 makes -1. Again, I'm not just going to connect the dots. Some of these graphs look really funky, and if I just try to connect the dots, I'm going to miss some points. We're really not plotting that many points. Okay, -2 sine of x. Make sure you close that parenthesis. It doesn't matter which one you type in. It's probably easier to type in the top one, minus cosine of x. Okay, again, we got to fix our window. I'm going 0 to 2 pi. I'm counting by pi over 2's. I really only need to probably go to -4 this time. And then I can draw that graph. Okay. Now again, I'm going to try to find these key points. Yep, starts at -1. You notice this one is at -2, but that one's here, right? That one's right about here. It looks like it's going to definitely peak before, so it's going to go down a little bit more before it comes up to that point. I'm going to mark you down if you don't have that kind of thing. So make sure you are, drawing this, looking at the calculator, finding these key points, right? Again, this point here, which is here, is not at the actual peak, right? That point's really about right there. So it's definitely going to peak somewhere in there before it comes down, okay? And then looks like it just goes straight to that point from there, okay? Make sense? Okay? Let's try, I'm going to show you a really easy one. Sometimes, if you see something like this, notice sine 2x, sine 2x. If it's the same trig function and it's the same period, well, I have 4 of these plus 2 of those. That's the same thing as 6 of those. I can just add those together. That's a whole lot easier to graph. My period's pi over 2. This would be pi over 4. This is going to be, 3 pi over 4. I know my amplitude is 6. I can just go up and down 6. This is a sine graph. So midline, peak, midline, peak. I don't have to do anything more than that, and I'm done. Okay? So sometimes they are super, super, super easy. Some of these are going to be, pretty easy. Some of these are going to be a little bit more involved. Some of these graphs look really, really funky. But just know, when you're looking at some of these equations out of the book, let me focus this in here. Okay, so let's take some of these. Like these two, that's going to be easy. I can just add those together because those are the same sign, right? This is 2 of those. I can just graph 3 sine of x. This one I can't add because they're different, but they are the same period. If you look at a question like number 13, that one's actually going to be pretty tricky to graph because if you look at that one where it's y equals sine of 3x plus cosine of 2x, okay? The problem with that one is going to be the periods, okay? So if you look at this one, the first one has an amplitude of, or a period of 2 pi over 3. The second one has a period of pi. So what that means, and why that's kind of tricky, is if you think the green one is going to be done every time it gets to pi, right? 1 pi, 2 pi, 3 pi. The second one is going to be done every 2 pi over 3, which means it'll be done 2 pi over 3, and then it'll be done at 4 pi over 3, and then it'll be done at 6 pi over 3, which is 2 pi. So I'm going to have to draw 3 of these graphs and 2 of those graphs. Okay, so this one is going to be, a lot of it's going to be spacing. So what I would do is I would go get that 2 pi over 3. This is going to be 1 pi over 3. This is going to be pi over 6. So what I would do if I were you, this is pi over 1, 6, 2, 6, 3, 6. What I would do if I were you is I would space this out. Spacing is going to be critical. What I would do right away is I would count by sixths all the way to 2 pi. Because I know this graph is going to go to 2 pi. And basically I'm going to have to count it by sixths all the way out there. 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6, 8, 6, which would be 4 pi over 3, 9, 6, which is going to be 3 pi over 2, 10, 6, which is going to be 5 pi over 3, 11, 6, 12, 6. Okay? So the reason I do that is now my spacing is pretty good. And now I can really focus on drawing this graph. The first one we said was going to be done by the time we got to 2 pi over 3. So it has an amplitude of 1. Sine graph. Okay. And it looks like this. The other one has a period of pi, right? So that one's going to be done by the time it gets to here. So it's going to have a few other points here, and that quarter point would be right in here. Okay? So, and then 3/4 would be right in here. It actually wouldn't be a bad idea to draw a few extra points, because this one is going to be pretty nasty to graph. This is going to be cosine graph here, midline, bottom peaks at -1, midline, top peak. So you can start to see that when I plot that point, first off, I'm going to have to draw more graphs, right? I'm going to have to draw another green graph, and I'm going to have to draw 2 more of the blue graphs. But you can start to see, some of these points, 0 and 1, I can add that together. This one here, I got 1, and I'm going to have to estimate that. This one here, I'm going to have to estimate. This one here, I'm going to have to estimate. But this one here, I know that point, right? So some of these points, I'm going to have to add them together. I'm going to have to estimate. Some of them I don't. But either way, I want to plot those before I grab the graphing calculator, okay? So try some of these, and let me know how it goes, and let me know if there's any questions. Okay, I will talk to you guys later.